is on surface area of pyramids and cones, and then we're also going to do a little bit of surface area and volume of spheres. Okay, so a pyramid is something that has a single base, and it goes up to a point, right? So a polyhedron in which the base is a polygon and the lateral faces are triangles, they go to a common vertex. A regular pyramid is one that has a regular polygon for its base. So in this case, this picture off to the right would be a square-based pyramid. That would be a regular pyramid because it has a square at the bottom. All right, so number 1. So the Great Pyramid of Giza in Egypt is the only remaining 7 members of the 7 wonders of the world. The 7 ancient wonders of the world. It is about 231 meters on each side along the base, and it's about 139 meters high. What is the surface area of the pyramid? Okay, so this is similar to what I was just doing, huh?
You could probably Google it.
Probably, I bet you could. So if we want to figure this out, we need to break it into its different pieces right now. So we're going to break it into the base, which I'm going to call big B, and the base is a square, right? So the area of our square is going to be 231 multiplied by 231. So 231, squared. So that ends up being 53,361 meters squared, right? So we have that part. Now we have 4 triangles that make up the front side, the left side, the right side, and the back side. So we want to figure out the area of one of those triangles. Okay, so let's imagine we have this. We'll do this triangle, it's fine. If we have this triangle here. Okay, if we're doing our 1/2 base times height, it definitely has a base of 231, but we don't know the height. So that's what I was saying is when you need to go over here to the center of this other side. Let me kind of draw it better. And we need to find this distance going straight up. Okay, this is called the slant height. You can see it better on this picture up here. Do you guys see that? So we find the slant height. That's going to be the height of one of the sides, so we'll be able to do our 1/2 base times height. So we find that with the Pythagorean theorem. So we have 231 was the whole side, so I have to divide it by 2, right? So I do 231 divided by 2 is 115.5, and we call the slant height L. Don't ask me why. I guess because the second letter in slant is an L. Why do we call it an L? I don't know. So it's an L. So we're going to do 115.5 squared plus 139 squared is equal to L squared. Let me find it. 115.5 squared plus 139 squared under square root. We end up getting L. L is equal to 180.724.
Is that even after you square root it?
It is after I square rooted it, yep. So I put that in. So I have 1/2 base times height. I want to make sure that I'm really good with my calculator. I keep that number stored, right, Charlie?
Oh, yeah.
And I'm going to multiply by 0.5, and then I'm going to multiply by 231. So the area of one of those triangles is 20,873.649. Again, this is in meters squared. So how do I put it all together?
Multiply the area of the triangle by 4 and then add
Yep.
that to the...
So we're going to do 4 of the triangles plus 1 of the bases, right? So I'm going to do times 4, and then I'm going to add that 53,361 number. And I end up getting 136,855.598. Oh, I put my comma in the wrong spot. That's awkward. All right, there we go. 136,855.598 meters squared. Or, you know, you could Google it, which you guys were saying. It's so much more fun to actually find it, right? And who knows what happens when you Google. I'm sure you've all gotten wrong answers from Google. There's a lot of things out there on the internet. All right. So, the next one says a regular pentagonal pyramid has a base with side lengths of 18 inches. So we have a pentagon, and we have 18 inches, and it's going up to a point to create that pyramid. And I was nice. I gave you that for a pentagon, the apothem is 12.4. I've rounded, but I'll give that to you. So in the slant height, oh, I even gave you the slant height. How nice of me. Is 24. So find the surface area of the pyramid. So for our surface area, we'd say, well, I got one of those bases, and I have 5 of those triangular sides. That's a 5, not an S. My 5s always look like S's. So I get my area of my base. I could do it lots of ways. I could find little triangles in that pentagon, right? Do you guys remember the formula for a regular polygon? 1/2 apothem and perimeter. Perimeter times apothem, right? So 1/2 PA plus 5 times the triangle. So I'm going to have 1/2 my perimeter. Ooh, perimeter. 90, right? 18 times 5. Apothem, 12.4. That was so nice of me. 5 of those triangles. Well, a triangle is 1/2 base times height. Do we have the base? You know what this is? 18. What's the height? 24. You with me? They're spacing out. Jeez. Base and height of that triangle. 90 degrees there. And we put it all together. 0.5 times 90 times 12.4 added to 5 times 0.5 times 18 times 24.
Where did the 90 come from?
That's the perimeter of that base. So it's 18 times 5. So we get 1,638 square inches. Could I be tricky and I put some of the units in inches and some of them in feet? Wouldn't that be fun? So then you would change them all into inches or into feet, right? All right. So we can do this for every single pyramid. We can break it into its different triangles. We can break it into the different bases, right? It's not that hard to do. Like we just did it twice. So you could do your entire homework like this. But there's actually a formula. Okay, so I'm going to tell you what that formula is right now. So it has to do with the slant height. And you see how we had, this was like, well, let me take you through the why right now. So it says, think about a regular hexagonal pyramid. The area of each lateral face is what? So we have this like lateral face coming up off of it. And if I want to get the area of one of these faces, I have to use that L in there somewhere, right? So the area of each of those faces, each triangle, ends up being 1/2. What was this unit right here? Like, or not unit, what do we, like, I would say S times L. Do you see what I mean by S? It's like a side length of that. 1/2 S times L. How many of those do we have? How many triangles do I have? Like the lateral faces. I have the one on the front, the one here, 2, 3, 4, 5, 6. Yes, I have 6. So we multiply by 6. This would be the 6 triangles. Would end up being this. Okay? What about the one base? Well, that's going to be the 1/2 PA, right? Perimeter times apothem. Okay, so the way that we write this is we do our area of our base, which you can write as B. Well, let me write S is equal to. S is equal to our area of our base plus, and instead of writing this out, 1/2 S L times 6. The 6, where did the 6 come from? The number of sides of this shape. What if I had your favorite, a heptagon?
Yes.
That would be a 7. What if I had a pentagon?
Sorry, I'm very tired right now.
If I had a pentagon, it'd be a 5, right? So this number here changes. I'm going to pair these two things together. What is 6S in the context of this problem here? 6 times the side length, which is the perimeter. It's the perimeter.
No way.
So every single thing does the area of the base plus 1/2 PL. Okay, so if you know that formula, then you'll be fine. You can use that formula. So it says why? Think about a regular hexagonal pyramid. The area of each lateral face is 1/2 S times L times 6, and the perimeter of the base was 6S. So we take that 6S and we replace it with a P. Okay, so let's use our formula. So it says a regular pyramid has a hexagonal base with a side length of 4 and a slant height of 9. Find the surface area of the pyramid. So we're going to say surface area is area of our base plus 1/2 perimeter times slant height. L is slant height.
Is P times L in parentheses?
It could be. You don't have to. Yeah. So let's find the area of the base. Okay, well our area of a polygon is always 1/2 perimeter times apothem, right? So can you identify the perimeter and identify the apothem? You guys are frantically writing these things down. All right, what's the perimeter of this problem? I have to go back. So the side length is 4. It has a hexagonal base, so the perimeter would be 4 times 6, which is going to be 24. You good now, Ian? So our perimeter is going to be 4 times 6, which is 24. Our slant height is our L, that's 9. Okay, but the only thing we don't have is our apothem. So let's think about a hexagon for a base. Oh, that is a terrible hexagon, not my finest. How do I get this apothem? A. Well, I know that the side length is 4, which means I have 2 and 2. Do you guys remember why we like a hexagon? 30, 69 triangle, so I have 30 degrees here, 60 degrees here. It is. Apothem is 2 radical 3. You got it. So our surface area is going to be 1/2 PA, so perimeter is 24, apothem is 2 radical 3, plus 1/2 P, which is 24, times the slant height, 9. So it looks like that. So we get 24 root 3 plus 108. If that bothers you and you're like, that doesn't look like a number, because for some reason you guys say that. You're always like, oh, I need it as a decimal. You can find it as a decimal if you want. This would be 149.569 cubic, or square feet, right? Okay, does this make sense? Okay, so you know how our formulas for the cylinders and prisms was pretty much the same? Only for one of them I used P and one of them I used C circumference. Similar for this, okay? So for a cone, you could actually, you could use the surface area is equal to the area of a base plus 1/2 PL. But just know that you got to be kind of careful because it's not perimeter. What would we call this going around? Circumference. So I would probably think of it as area of our base plus 1/2 CL. Okay. I can go into why this is true. Do you want me to show you why it's true? You don't care. You don't care. It kind of pains me. It's pretty cool, but that's okay.
Sure, Mrs. Cox.
Koki, you should figure out why it's true. He likes doing this stuff. He's a pure mathematician. We've talked about this. Why this formula ends up being pi r squared, that's the area of the base, plus 1/2. Notice how our circumference is 2 pi r L. See how the 1/2 and 2 cancel? We end up getting pi r squared plus pi r L. Okay, so there's a really cool thing that shows, like I could show you why this is pi r squared and this ends up being pi r L, why that area is pi r L. So that's what I'm telling you, Koki, you should figure out, think about why that has to be pi r L, the area of that little Pac-Man shape is pi r L. All right, so anyway, so here's our formula. So I believe there's a box for that, right? So our surface area is going to be pi r squared plus pi r L. So r is the radius of the base, L is the slant height. Okay, so number 1, so it says find the surface area of a right cone with base diameter of 10 inches. That means our r is equal to 5. And slant height of 8 inches, so L is equal to 8. So it's very easy. We end up getting pi r squared plus pi RL. Look how easy that is. So pi times 5 squared plus pi times 5 times 8. So I have 25 pi plus 40 pi. So my answer is 65 pi inches squared.
Why doesn't the pi like multiply?
You can. Like if you want to find 65 times pi. Does that what you're saying?
Well, no, because there's 2 pies. Wouldn't it be like pi squared?
Well, you're adding them. It's kind of like if you had like 5x plus 6x, you'd have 11x. It wouldn't be like 11x squared. So if you're adding them, it just becomes 5.
Why is it 2?
Yeah, that's what.
So if you have 5x plus 6x, we don't say like 11 2x, right? Does that make sense? We say just 11x. So the easiest way to think about this is to pull out the GCF of pi. Then you'd have 25 plus 40. So you're adding those together, the 25 and the 40, and getting 65, and then multiplying by pi. So think of it that way, I guess. All right. So number 2. Oh, I forgot my inches squared. All right, so find the surface area of a right cone with base radius of 3 and height of 4. Now, careful, this is height, not slant height, right? So sketch it out and think about it. Your height is 4, your radius is 3. What does the slant height have to be?
5.
Oh, you're so good. You're allowed to graduate from geometry if you recognize 3, 4, 5 right triangles. So we have 5 there. So that's our L. So you have the surface area is pi r squared plus pi r L. So it's pi times 3 squared plus pi times 3 times 5. So we have 9 pi plus 15 pi, which ends up being 24 pi. Inches squared. Easy? Thumbs up? Thumbs up. All right. Spheres. Oh, my sphere got cut off. So sad. It's like that. So a sphere is all points in space that are an equal distance from a given point called the center. So we had a similar definition for the circle, right? But that was all points in like a flat space, like in a plane, that are equal distance from a point. So imagine I have maybe one of my obnoxious things hanging from the ceiling. That's my point. If I talk about all things that are an equal distance, like my distance from that point, it would create a 3-dimensional object, right? So maybe it's something here, maybe it's something here, maybe it's something here, right? Do you see what I'm saying? So it's a 3-dimensional object. It's this sphere. So the radius of the sphere you can find in any direction. So a radius could be like here, or here, or here. These are all the same distance. So they're all r. I think you guys get that concept. That's not a hard concept. So the surface area of a sphere ends up being 4 pi r squared. I can show you why that's true with calculus, but it might be a smidge over your head. So I'll just wait until you see that in calculus. It's a pretty easy formula though, right? It's like the area of a circle times 4. So find the surface area of a sphere with radius of 100 meters. So our surface area is going to be 4 pi r squared. So 4 pi 100 squared. 100 squared ends up being a 1 with 4 zeros, so it's 10,000. So this ends up being 40,000 pi.
Mrs. Cock, can you teach us to make an extra credit?
Yeah, teach you all the calculus required in the next 2 weeks.
Yeah.
All right, so a leather ball has a radius of 5 inches. Estimate the amount of leather used to cover the ball. Okay, so we have some kind of leather ball. It has a radius of 5 inches. So our surface area is 4 pi 5 squared. It ends up being 25 times 4, which is 100 pi inches squared. Easy enough?
You did so fast.
Do the 5 squared first, and multiply by 4. 4 quarters is $1, right? We got this. All right, so we might talk about something called a great circle. Think about a great circle on a sphere. The greatest circle that goes around a sphere. Go back. So if I'm tying a ribbon around a basketball, where's the largest ribbon going to go around? The very center of that sphere, right? So this is going to be the great circle. So in our picture of a sphere, something like this would be the great circle, right? Something like this would not be a great circle. It'd be a smaller circle. You get it?
I thought you meant
I know, it's weird. All right, so the volume of a sphere is 4/3 pi r squared. Oh, whoops, r cubed, sorry. I was going to say there's a cool relationship between the surface area and the volume using calculus, but See, these things are things you get to look forward to someday when you take calculus. Are you all planning on taking calculus someday? Oh, fun.
One day.
All right, so find the volume of a sphere that has a diameter through the great circle of 50 inches. So if we have a diameter of 50 inches, that means our radius is 25. All right, so same idea. So we're going to do the volume is equal to 4/3 pi 25 cubed. So I'm going to do the 25 cubed part first. Multiply by 4. So I get my 4/3 pi times 62500, and then I multiplied by the 4 over 3. 3 doesn't go into it. So I got 625, hang on. Oh wait, hang on. The 25 cubed was not this number. I already had multiplied. So 15,625. So I get this over 3 pi. So 62,500 over 3 times pi. If you wanted to find all that and then multiply pi n, it would be around this. So if I talk about like the amount of air in the ball, that would be a volume. Like this many cubic inches of air.
So for the quest, are we gonna have to know all these formulas?
All right, number 2. If a basketball is 78 centimeters in circumference around its great circle, so circumference is 78, find the basketball's surface area and volume. Okay, so the only thing that we need in the surface area and volume formula is R. How do I find R? Colin, dang it, every day I do that. I don't know if it's the N at the end. I'm just going for it. Colin. So 2 pi R equals 78. So I get R is equal to 78 over 2 pi. So I get R is equal to 39 over pi. Okay, you could find a decimal if you want to, if you're more comfortable with a decimal. But let's find the surface area and let's find the volume. So I have 4 pi r squared for surface area. Okay, here's a little cool like math reducing stuff going on. See how when I square that? When you square a fraction, the top gets squared and the bottom gets squared, right? So I'm going to have 39 squared, which is 1521, all over pi squared. So if you want like a really precise answer instead of using decimals, do you guys see how one of the pi's on top and one of the pi's on the bottom goes away? So like this pi goes away with one of these pi's and I'm left with a pi. So I take that 1521 times 4. So my exact answer for this would be 6,084 divided by pi. That would be my surface area. And my units would be like centimeters squared. So the volume would be 4/3 pi, again, r cubed. So try to simplify this one so that you still have a pi in the answer. Can you really struggle? Okay. You guys see how you get 59,319 over pi cubed? The pi and the pi cubed reduce out to pi squared. Okay, these also reduce. So you can reduce those out, and then when you reduce them out, multiply by 4. So you end up getting, did you guys get this number, 79,092 over pi squared? That would be the exact answer for volume. So kind of get used to doing the exact answer, because as you guys advance in your math classes, which you're so close to doing, this is the last section, as we said, of geometry right here. So you're so close to Algebra 2. You want to keep your answers as precise as possible. Okay, is that it? One more? Same thing. So a sphere is made from a steel cylinder. All the steel is used when compressing the cylinder into a sphere. So we're starting out with a cylinder. And we're going to melt all the steel. And then we're going to form a sphere. Like a ball bearing or something that would be something made out of like steel. Does that make sense? Okay, so the cylinder had a radius of 2 centimeters and a height of 16. We want to know what the radius of the sphere is if we use every single bit of that steel for the ball bearing. Does that make sense? The sphere. So we're going to find what, volume or surface area? What do you think? Volume, because I'm guessing that it's like full, like it's not like a hollow thing, right? So volume. So how do I find the volume of the cylinder? Do you guys remember the formula?
Oh, it's
Not 1/3.
Oh.
Area of the base times the height. Remember we used Isabella's water? So I get pi squared. I get pi r squared h. So I get pi, r is 2, h is 16. So I get my volume is equal to 64 pi. Okay, we want that entire volume to go into the 4/3 pi r cubed for this volume, right? So I'm going to replace my 64 pi, my v with 64 pi, right? Thoughts?
Wait. How did
So I'm solving for r, that's what I'm trying to get. What if I divide by pi on both sides? What happens?
Oh, you get rid of pi. Yay.
That makes it nicer. So we have 64 equals 4/3 r cubed. Can you solve that? Take your 64 and multiply by 3. And divide by 4. You could have done that in one swoop if you wanted. So we get 48 equals r cubed. How do I get rid of an r cubed? Do you guys know how to do that? If it had been r squared, what would we do on both sides? We take the square root. So this is going to use something called a cube root. So the cube root looks like this. Do you guys know where that is on your calculator? So if you hit math, well, hit a 3 first and then do math and go down to option 5 on mine. It will do cube root of 48. There's actually one that does have cube root there as well, actually. So we get 3.634. Do you guys all have that number? So that's how big our radius would have to be. All right, that's it. All right.
Wait, could you do the last one for that? Sorry.
Yeah.